Hello everyone. Am I recording the solutions for 2019 H1 paper 2 Tmjc, right? For the section B, question 6 and question 7, because maybe I won't have time to go through in the lesson later. Okay, so 6a, Newton's second law of motion is bookwork, right? So there's no issue. I can show you the solutions here. Right? Newton's second law of motion states that the resultant force acting on the body is proportional to the rate of change of its momentum, and the change takes place in the direction of the force. Right. So next, B part 1. Draw the forces acting on P. Okay. So remember, one of the key things when you're drawing a free body diagram is to label the forces in full, the name in full. Don't just leave it as W or N, right? So here, the answer given by Tmjc was contact force. I think it's fine if we call it normal contact force also. Most of you would actually, I think, write normal contact force simply because the force is perpendicular to the surface, right? So by definition, that's the normal contact force. So both answers are acceptable, right? 2 marks if you got both the arrows and the names, you can get them correct. Okay. Next, calculate the acceleration of P. This one, right? This is the answer provided. But I think maybe it would be easier if you actually draw the diagram and take a look, right? So if you have drawn the diagram, you would see that this is mg, right? You would see that normal contact force doesn't provide any component of the force in the direction downwards of the slope. Therefore, if you were to resolve this force, that means you find a component of this force perpendicular or parallel to the slope, and that means this is 90 degrees, right? You find that the rate value here is actually mg sine 40 degrees. By now, your resolving of forces should be pretty strong. So your net force, right, F net by Newton's second law will give you ma, right? Then you actually get your net force is mg sine 40 degrees to give you ma, right? And with that, you can actually solve that a equals to g sine 40 degrees, right? Yeah, so this is the part that maybe the solution from Tampines wasn't that obvious, right? So I think maybe it makes more sense to explain this in more detail. Okay, the next part in part 3. Part 3 is relatively difficult. The original solution from TM was very short, so I took some time to write it out again. Right, while y'all were trying the paper, I actually took the time to make the answers better. Okay, so I separated out. So I looked at for Q, which is dropping, right? Q is falling free fall. So that's not a problem. The height that it falls using the equation, right? S equals to half AT squared. So this is the general equation. If we apply to Q, the distance it falls is h, the acceleration is g, which is 9.81, and the time that it took is t2. So we have t2 squared equals to 2h over g, right? Not an issue. We repeat the same for p, but for p we need to maybe think of it as, the height is here, h, right? You can think of the distance it moved here as s, right? So if you resolve, right, it is 40 degrees, you can see that sine 40 degrees is h over s, which allows you to rewrite s equals to h over sine 40 degrees. Agree? Yeah. So the distance traveled is therefore this, right? Therefore, using the same general equation, right? But now you must use the distance traveled along the slope, which is this. The acceleration is acceleration along the slope, which we have also calculated from here, which is g sine 40 degrees, and therefore here, right? So you have s equals to half at squared. A is the a that you have calculated from part 2, right? So with this, you get a new T1 being 2h over 2 2h over g sine square 40 degrees, right? Pardon me, I forgot to include the 40 degrees here, right? So oops, cannot save this, because I gotta send this to you. Yeah, can I send it with the drawings? Yeah, I'll just send it with the drawings. Yeah, whatever, right? So there you go, right? And then after that, you still must do the next step, which is to t1 square over t2 square. Then you do this, and you realize that 2h and g cancels out, right? And then you must square root both sides of the equation to get 1.56. It's not easy at all. These 3 marks, yeah, pretty challenging, I would say. Even I had to look at it like a few more times to think through if that's really what they want to test, right? So yeah, part 5, part 4, right? By reference to a conservation law, state and explain the ratio of v1 over v2. So this one I also improved upon the answer, right? The answer by the original one, if you check out our school's portal website, the previous answer was pretty brief, right? So yeah, so use the conservation laws. Obviously, it must be conservation energy, right? Cannot be Pocom or whatsoever, right? So since the slope, and you need to add in the idea that since the slope is smooth, because if not, when P is sliding down the slope, it will do work against friction, right? So slope must also be smooth, must be stated, and therefore the loss in GPE of both P and Q, right? Loss in GP of P and loss in GP of Q must be the same. And because the slope is smooth, the gain in KE of P and of Q must also be the same. Correct or not? So if they have the same energies using the equation half mv square, the speeds must therefore be the same. And notice I use the word speed and not velocity, because although the speeds are the same, the direction of the speeds are not, right? For Q, it will be directly down. For P, it will be at a diagonal, right, at 40 degrees. All right, so, but because the speeds are the same, the ratio, right, just magnitude-wise must be equal to 1. Okay, so that's the answer for part 4. Part C, what is meant by head-on collision? This is the one that I think the solution from TM was quite brief. I think this is a much better answer. I highlighted in yellow, right? So when two objects have a head-on collision, right? So this is like the preamble of how you scope the question, right? Because you can maybe they have 3 objects doing head-on collision, very difficult to explain. So you just use 2, right? The velocities of the objects before the collision and the velocity of the object after the collision must be on the same straight line, right? Are on the same straight line. So another word is collinear, right? So I could replace the word on the same straight line as collinear, collinear. But in an explanation question, especially for Cambridge, I would rather use simpler terms, right, on the same straight line than something like collinear, which is a bit more that requires a bit more knowledge, right? And in fact, they can ask you what does it mean by collinear. I've seen this question before. I think in a prelim question, yeah. So they can ask you what is collinear in collision, right? What does collinear mean? And you need to explain that the velocities before and after are on the same straight line. Okay. Next, elastic collision. What does it mean? Yeah. So I would totally use this. And this is the one that our school has been using. You can see I've cancelled out the solution by Tmjc. Yeah, because this part that's cancelled is the result of both elastic collision and POCOM. It is not the definition or the key explanation for what is an elastic collision. Right? In elastic collision, it just means that the kinetic energy before and after the collision, right, stays the same. It is not throughout. Watch, if you wrote the word throughout, please minus 1 mark. It is before and after the collision stays the same. Okay. Part 2, C part 2 is a part that you definitely must know by now. This 4 marks, very nice. And one of the ways that I always teach my students when it comes to collision question is to always draw the diagram, right? TMJC's one didn't, so you should draw before. P is coming, right? And you put all the information on the diagram, right? So P is coming at a velocity of 6.2, given from the question, right? Q is at rest, also given by the question. After the collision, P is, we can take it that P is moving to the right with velocity v1, Q is moving to the right with velocity v2. And you should also put in the masses, 3.2, 5.6, right? So that means when you're solving a question, you are doing information hunting, right? And organizing of information first, right? So that when you are writing out the question, the numbers, you're not trying to do both at the same time, which increases the likelihood of making careless mistakes. Okay. Right. So that's that. Once you organize information, then you know by POCOM, right? Conservation the momentum before the collision and the momentum after collision must stay the same. And in this side, I think they take right words as positive, right? So you therefore have 6.2 times 3.2, right, equals to 3.2 times V1 equals to 5.6 times V2, right? The mass of Q times the velocity of Q, the mass of P times the velocity of P. Next, you use a relative speed of separation equals relative speed of approach. Yeah, I think they messed up the direction, so it should be RSA or RSS. Right, so speed of approach is obviously 6.2 minus 0. Speed of separation should be V2, the one that's going away, minus V1. So therefore, there you have it. So if you manage to have these two equations with the numbers correctly substituted, you get 1 mark each, right? Next is just mathematical solving. You should get these two values. So V1 being negative means it's pointing to the left. V2 is positive means pointing to the right. Okay. Oh, part 3. That means I should change this. Take right as positive. So please forgive me. Right, I wasn't very consistent. Like right where it says positive. Right. Okay. So here you must have negative of a positive value. Right. So if you take right as positive, there are a few ways to solve this. I think there are 3 different. TM gave 3 different methods. I gave the one in the middle, right, to solve, and I also elaborated a little bit on the first one. Okay, so let's see. Do you want to find the average force that Q exerts on P? Okay. First method is to find the average force on P. They use impulse momentum theorem, right? Using impulse momentum theorem. Okay. The force times delta T equals to change of momentum P, right? No problem. So that's the word equation. Then this is a symbol equation. Then we substitute, right? Delta T, if you look at page 21, is it? No, page, page 18, right? Part C, third line, right? You'll see the delta T as 0.35 seconds, right? That's why there are a lot of information finding. If you've done beforehand, it will make your life a lot easier. Momentum, right, is mass times velocity. So the mass is 3.2 of P. Final velocity, it is moving to the left, so you have negative 196 minus the initial. The initial momentum is to the right, so therefore it's minus a positive value of 62. Therefore, you should get a negative 7.21 newtons, right? Using Newton's second law, which is the one I think I prefer because you're trying to find the force, just use Newton's second law, rate of change of momentum of P, delta P, delta T. So if you do this, so same thing, the problem is I defined it the other way at first. So let me change. So final velocity is to the left, so therefore is minus 1.69. Initial velocity to the right, so you must minus a positive value of 6.2. That's why you should get a negative value of 7.21 newtons. Okay, let me save that. TM also gives a third method, which is try to find the force on Q first, and you find that it's actually positive. Then the force on P, because it's leftwards, then it's negative. Right? You can try to understand this method, but I'm not going to spend too much time. Yeah, you can just take a look, see if you understand, right? They use Newton's third law to find. Quite interesting. in some questions using this method might save you some time. Okay, as you can see here, because Q did not have an initial velocity, you just have to take the final velocity, right? Final velocity here as the answer, like this, right? Because it's going to the right at the speed of 4.51, the mass is 5.6, you can get this force directly, right? So it's pretty fast. And then by Newton's third law, you just add a negative sign. Therefore, the force, if the force on Q is towards the right, the force on P must be towards the left, right? Towards the left, correct? And therefore, minus 72.2 or 72.1. Yeah, so there are different ways to solve this, right? I didn't calculate this because it wasn't one of the values. I'm not sure why there's a round-off issue. The answers being different, but you can of course check it. It's just a round-off issue, not a big problem. Right, with that I come to the end of question 6. I will start another video for question 7.